Okie dokie. Welcome to BIT 2406, Chapter 2, Part 2. We're just doing 16 and 17 here. Let's get into it. So, we mow lawn service. Blah, 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 blah. There will be 6 major snowfalls next winter. They can't take more than 2 days to remove snow after each snowfall. They are working 10-hour days. They can do a driveway in 1 hour. They can do a parking lot in 4 hours. That's a business parking lot. The variable cost per job is $12 per driveway and $47 per parking lot. They will have a demand of no more than 40 homeowners, so like no more than 40 driveways, and no more than 25 businesses or 25 parking lots. They plan to charge $35 for a driveway and $120 for a parking lot. They want to know how many jobs of each type will maximize their profit. So formulate a programming model. So we're going to start with the profit equation. We'll call it Z. Profit. Think about profit here for a moment. Profit incorporates not just the money they're making, but also the cost for the jobs here. So revenue minus cost, essentially. So if they are charging $35 per driveway, we're going to call the number of driveways X1. And they're charging $120 for each parking lot. So X2 we will call parking lots. So we'll call parking lots X2. That's what they're charging. That's the revenue they're going to bring in for each type. But it's going to cost them $12 per driveway. So we have to subtract 12 per driveway, or 12 times X1. And it's going to cost them $47 per parking lot. So we subtract 47 X2. Simplifying this, 35 X1 minus 12 X1, we get 23 X1 plus 120 minus 47 X2, that would be 73 X2, I think. So I'm going to go with that. That's our profit. This is what we want to find a max of. That's the goal. Let's talk constraints. Again, we're using X1 and X2. They say something about there's a demand of no more than 40 and no more than 25. So I think X1 can stay less than or equal to 40. X2 can stay less than or equal to 25. What else do we know? Something about they can remove snow from a driveway in 1 hour, parking lot in 4 hours. So let's do like an hour's inequality here. So this is the fun one. So each driveway takes them 1 hour. So we're talking 1 hour per driveway. But each parking lot takes them 4 hours, so 4 hours per parking lot, and that has to be less than or equal to the total number of hours, not just that they have in a day, not just the 10, and really not even just the 10 times 2, because keep in mind, it's 10 hours per day, and they have 2 days after the snow stops falling to remove that snow. But not just the 2 days and the 10 hours, it's 6 major snowfalls. So we have to consider the entire season. So not just 10 times 2, but 10 times 2 times 6. And I think that's it. So we multiply all that. 10 times 2 times 6 is 120. So less than or equal to 120, x1 plus 4x2, right? These are the same inequalities, right? Just the second one is simplified. I think that's it. Are we forgetting anything? I don't know. I don't think so. So I'm going to check our answers here. Maximizing 23x1, 73x2. Yep. X1 is less than or equal to 40. X2 is less than or equal to 25. X plus 4x2 equals 120. Yep, looks good. And then, of course, they did the X1, X2 just have to be greater than or equal to 0. That's kind of given. You won't have negative numbers of driveways and parking lots. So I guess we just have to state it just to be extra clear. Now, again, I'm just going to explain the graph here. So to solve it, what they did was graph these constraints, right? So graphing, let's see, this one, the third one, likely gave them this line here. And then x1 being less than or equal to 40, that's the vertical line along x1 equals 40. And then x2 less than 25, less than or equal to 25 is the horizontal line. And yeah, because it's all less than or equal to, that's why everything is shaded below. And anyway, it gives us these intersection points of A, B, and C. And D, actually. Okay, so they've done, so you kind of consider the ordered pairs for A, B, C, and D and plug them in to the Z equation, the profit equation, and they found out that C was optimal, meaning it's the ordered pair of 40, 20, the location of C, that would produce the maximum profit of the points A, B, C, and D. So like the ordered pair C produced the highest profit. I hope that's clear. That's why C is optimal. Yeah, okay. Let's see. So that was, I think, all of 16. Let's talk 17. They say if Jeff and Julie pay $3,700, if it costs them $3,700 for removal equipment, will they make any money? Well, let's see. It looks like they already made, or like at their max profit, they're making $2,380. So if they're making a profit of $2,380, and then all of a sudden they buy some snow removal equipment for $3,700, will they make money? Probably not. So I'm gonna go ahead and just run a little 17 here. I'm gonna say fucking no, because they're only making like $2,300, but if they have to spend $3,700, you're in the negatives. Okay. So part B. If they reduce their prices to 30 a driveway and 100 per parking lot, they will increase demand to 55 and 32. Will this affect their possible profit? Now, I might have to get into the graphing side of things here, unless they've done it for us. Nope. Okay, yeah, I'm gonna take my shot at this. So bear with me, please. I'm gonna open up Desmos. So let's see what we need to modify here. So they said their demand, they're just changing demand and the prices, right? So 30 and 100. Okay, so give me just a sec. Let's talk changing their prices first. So changing their prices will totally affect our profit. So let's write a new profit equation. So their prices are going from 30. Let me do a little copy paste action here. So all right. So their prices are going from 35 to 30, and then from 120 to 100. Okay, and then their demand though is going up. So these demand equations or inequalities are going up. So we're talking 55 a driveway for like max for driveway and 32 parking lots max. Okay, so let's fix our profit here. If we simplify this, let's write it down here. 30 minus 12, so simplifying the x1s, 30 minus 12 is 18x1 plus 100 minus 47, that's 53x2. So this is our new profit equation, and these are new demand inequalities, but we still have, what do we have? We still have this one, right? 1, 4, and 120. So that's just the hours it takes. Yeah, okay. So I'm gonna graph these and this and see what happens, okay? So Desmos, I'm graphing these guys. So just to be clear, I'm gonna use x1 is gonna be x and x2 is gonna be y, or vice versa. So like x is going to be less than or equal to 55. And then y I'm using as x2, right? So y is going to be less than or equal to 32. And then we'll do an equation here. We'll have z, or the profit, How do I want to do this? I guess I don't need to graph that actually, sorry. So I'm just going to do this constraint here. So x plus 4y is less than or equal to 120. Okay, so now let's get a good look at Desmos here. What's going on? So we can see kind of a similar situation, right? So the idea is that everything shaded below, so we're looking at these three critical points, okay? So it's created this region, kind of like trapezoidal region. It's hard to really define what I'm talking about, but like from 0 to 30 on the y-axis, and then all the way to there, and then on this x-axis 55. So like these 3 points are the critical points. So what we would do is plug each of these in to the profit equation, the new profit equation that we have, to see which one produces the max profit, something like that. So I'm going to assume it's the 55 and the 1625. So let's go up here. Talking 55 and 1625. What do they say? Will this affect their possible profit? So let's plug this in here. So like for x1 and for x2, I'm just going to use Siri for this. So watch this. We're going to plug in 55 for x1, 16.25 for x2. 18 times 55 plus 53 times 16.25.
It's 1,851.25.
185125. All right, so their profit shot down. I mean, like bombed, right? There's a chance, I wonder, this might have been one where like 55 might have been, no, that's probably it, unless 0.30 somehow better. Let me think about that real quick. 53 times 30?
The answer is 1,590.
Nah, it's not even close. Okay, just had to make sure. All right, so it would affect their profit. It would lower it by like $500. So that'd be terrible. Now, part C. They say alternatively, hiring additional people on a per job basis, blah, 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 will increase the variable cost, 16 a driveway, 53 a parking lot, but it will lower the time it takes to 40 minutes and 3 hours. Will this affect their profit? So let's talk about that. We have to change our profit equation again because now it's changing their variable cost. So they say alternatively, so we kind of have to restart with the profit equation here. Notice the key word is alternatively instead of something like additionally. Like if they had said additionally with these other changes we made, then blah, blah, blah. Then that would have meant we had to keep these changes, then make the new changes as well. Anyway, so variable cost is now 16 a driveway, 53 a parking lot. So 16 a driveway, 53 a parking lot. Okay. So let's calculate this new profit here. This is part C. 35 minus 16 is 16 plus 3. So that is 19. So we have 19x1. And then 120 minus 53. 120 minus 50 is 70. Minus 3 is 67. So 67x2. So this is our new profit. But what do they tell us? They say the time is 40 minutes and then 3 hours. So it's going to change this equation or inequality. So it's changing the parking lots to 3 hours, and what was once 1 hour is now going to be 40 minutes. So how many hours is 40 minutes? Well, 40 minutes is 2/3 of an hour. 40 divided by 60 is 2/3. So 2/3 of an hour times x1, blah, 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 less than or equal to 120. Okay? I think that should do it. So what does that mean we change on the graph? Really, it's just changing this here to 2/3 and then this to 3. And then we have our new intersection points that we can see here, 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 and here. Okay? So, yeah. So I'm going to make an educated guess that it's just the 55 and the 27.7, but I really don't know. But basically what we would have to do is test out all these points plug each of these ordered pairs into the new profit equation to see which one produces the max profit. Okay, so I'm gonna hope it's the 55 and the 27.7. 55 and the 27.7 repeating, so maybe 7, 8. Let me check the answers as I'm going through so I don't have to try a bunch of stuff. They had the 40 and the 125. Is there, or was it 40 and 25? Is there 40 and 25? No, I think I messed something up. Oh, you know what? I made this mistake before. Keep in mind the 55 and the 32 here were from the part B, and I said, we don't want to use the part B changes. We want to go all the way back. We want to reset to the original inequalities here. Sorry about that. That was my fault. 40 and 25. So learn from my mistakes on this one. Go back to all the original stuff and just make the changes for part C. Okay. So let me correct the critical points here. I think I guess it would just be that, and that, I guess. Yeah. So of these 3 points, the one that's going to produce the max profit has got to be the 40 and the 25. So 40 and 25 for this one. All right. 40 and 25 when plugged in here would give us some sort of profit. Let's see what that is. 40 times 19 plus 67 times 25.
It's 2,435.
2435. All right. 2435. Okay. So I can't remember how that compared. I think it's a little bit greater than the original profit. I don't know if I wrote the original profit down. They had it in the answers. It was the... Maybe they didn't. Oh, wait, yeah, they did. The 2380. So 2380 originally got increased to 2435. So the profit did go up. So before... So I think we have all this right now. No, not this winner. What was part A? What did I do for part A? Oh, yeah. Okay, that was the 3700. Okay. Anyway, so for part B, profit goes down. Part C, profit slightly goes up. That's what they had. What's part D talking about? If they combine the two alternatives, will this affect their profit? Let's see. While we're at it, we might as well do it. Let's combine the two alternatives. So combining the two alternatives would mean we try and just pick one of these to do here. So we change the revenue to 30 and 100. So I'm just going to modify part C. I'll do a copy though real quick. Let me do that again. So the changes were, the part C changes were the 16 and the 53. Part B changes were the 30 and the 100. So making those changes, but also the constraint equations, or the constraints for the demand, so the 55 and the 32. And then, what else? The hours. So combine, using the hours as 2/3 x1 plus 3x2 less than or equal to 120. So combining everything, which would really make me go back to what I had a moment ago. So it was this one with y is less than, what was it? 32 and then 55. Okay. Alrighty. So that should be it for these. Yeah, so we do. So all 4 of these now would be our critical points, or the possible things we'd want to try in the profit equation. So I'm going to hope it's the 55 and the 27.778. So I'll go 55 and 27.78. Yeah. So then we would plug that into the profit equation here, up here, and just see would that give us a max profit or not, a higher profit than the original one. So I guess while I'm at it, I gotta try it here. Let me write a simpler profit. It's 30 minus 16, that's 14, x1, 100 minus 53 is 47, x2. Let's try these. 14 times 55 plus 47 times 27.77.
It's 2075.19.
All right. All that work just to get that the profit did not increase. So about $2,075. Let me just try some of the other ordered pairs just to make sure, because I do not have the answer key for this, I guess. 55 times 0, that wouldn't do it. How about 36 and 32? That may. 14 times 36 plus 47 times 32.
The answer is 2008.
It's kind of close, but no. And then definitely not the other one. Okay, so I think this would be like our max profit that we could get with B and C's constraints combined, and this still is not as great as the original profit. So our best bet is just making the changes for part C. Thanks for sticking with me if you're watching this at all. Little rough. It's getting a little too late for me to try to be explaining math here, but I hope this made some sense. Hope this helped at all. If you have questions, let me know. All right.